Turning on a ray box, we use a single slit to produce one ray of light on a piece of paper. We then place a semicircular glass block on the light ray and trace around the block. We measure the length of the flat side of the semicircular glass block. Then we mark the halfway point of the length. Then we drew in the normal at this point. We mark the angle of incidence I and the angle of refraction R. The angle of incidence is the angle between the incidence ray, the ray coming out of the ray box, and the normal. The angle of refraction is the angle of the ray between the refracted ray and the normal. We then measured the angle of incidence and the angle of refraction with a protractor. We took the sine of both angles using a calculator and wrote the values onto a table on Microsoft Excel. We then moved the ray box so that a new ray of incidence reflected off the semicircular glass block. We used a ruler to mark the new light rays, both the ray of incidence and the ray of refraction. We then measured the new angle of incidence and the new angle of refraction. We calculated the sine of both values and added them onto the table. We repeated the process with 8 other light rays. In order to tell the rays apart, we numbered each ray. We graphed sine I against sine R with sine I on the vertical axis. In order to calculate the refractive index of perspex, the slope of the graph should be calculated. Thus, the angle of incidence should be divided by the angle of refraction. We calculated the index of perspex to be 1.37, while the actual index of perspex should be 1.46. Causes for this error were probably the results of human error in measuring the angles and plotting the points where the rays hit the paper.